the universe started, for the most part, seen as clarification. This has been something many imply as the theory of how things came to be. Various evaluations, besides the created works of enormous quantities of experts, support this thought, giving affirmation about how the universe began. Regardless, in the momentum universe of science, new innovation brings us novel examinations and viewpoints. These considerations challenge our previous doubts. Neil deGrasse Tyson has turned into a critical voice in this propelling universe of science. Now, something energizing is happening with the James Webb Space Telescope. This is something that could make us question the speculation of the old Big Bang. The James Webb Space Telescope has found 750 new universes. These universes are not what we anticipated, leading us to reevaluate what we assumed we knew about them. This telescope was intended to help us understand how universes formed, so it's not shocking that it's stirring up how we interpret the universe. In the past, experts said that the theory of how things came to be was the best explanation for how the universe began. By this hypothesis, around 13.7 billion years ago, the universe appeared through a peculiar vast event, similar to the dramatic story of the first experience with the world. However, the photographs from the James Webb Space Telescope have tested this thought. These photos show universes that are smaller, smoother, or older than what the hypothesis predicts. According to the speculation, as the universe extends, worlds ought to look larger the farther away they are. However, these tremendous systems don't keep that guideline. The hypothesis also states that at the start of the universe, all the stuff that makes up the universe was pressed into a small, superdense point called a singularity. This singularity was magnificently hot, hotter than anything we could measure or create. This idea of a singularity comes from a bunch of conditions in physical science proposed by Albert Einstein called general relativity. Inside the singularity, all the stuff in the universe was compacted into a tiny space with staggeringly high density, meaning there was a massive amount of mass and energy squeezed into a little space. In simpler terms, examiners have consistently said the speculation of the universe's beginning was the mystery of how the universe started. Yet now, these new pictures from the James Webb Space Telescope are making us question that thought. The universes at hand don't fit with what the theory expected, and the theoretical explanation of the early universe may not be as certain as we once thought. In our current understanding of the universe, we accept that all the energy in the universe began from an extraordinarily hot and extremely dense point called a singularity. This singularity serves as the starting point for all that we find in the universe today. After this singularity, the universe began to develop and advance over around 13.7 billion years to become what it is today. The expansion started with something many refer to as infinite expansion, where the universe developed unbelievably quickly, faster than the speed of light. It's as if the very fabric of space itself was extending, and everything within it was reaching out alongside it. This cosmic improvement helped shape the universe by making things more uniform and paving the way for universes, stars, and other gigantic structures to form. As the universe continued to develop, it didn't grow as fast as during infinite expansion. However, it still kept on getting larger. We call this steady improvement infinite development. Examiners have seen proof of this advancement through things like the way light from faraway systems changes color, known as redshift. Now we should discuss those stunning pictures of new universes taken by the James Webb Space Telescope. To most, these photos look dazzling, with various universes in a single frame, yet for researchers, it's somewhat of a shock. These photographs don't match what their hypotheses expected. Regardless, these universes are a lot surprisingly old. This challenges our understanding of how universes form and develop. As demonstrated by the theory of the universe's beginning, there are certainly more universes than we expected. The theory of the Big Bang made conjectures about how many universes there ought to be and how they should be distributed. However, the James Webb Space Telescope pictures show several more universes than guessed. This makes experts question whether the theory estimates are accurate. Some experts are, at least, beginning to feel a bit uneasy given that these exposures don't match their expectations at all. Another astonishing part of these new universes is their perfection, which conflicts with what the theory of how things came to be proposes. According to the theory, Universes should show oddities and variations in their forms due to how they formed and grew. However, the photos from the James Webb Space Telescope show systems that are strangely smooth, lacking the typical complexity and roughness expected during the evolution of the universe. Everything that makes up our universe was packed into a small space. As the universe broadened and cooled, changes occurred, and particles like protons, neutrons, and electrons began to interact with light and energy around them. These interactions played a crucial role in shaping the evolution of matter in the universe. In the initial minutes after the Big Bang, there was a process called nucleosynthesis, which involved the formation of light elements like hydrogen and helium. These elements set the stage for the development of stars, galaxies, and beyond. As grand history unfolded, this mixture of fundamental building blocks was a critical stage in the universe's improvement, progressing from a primordial sea of particles and energy to a state where matter began to coalesce. The theory of primordial cosmic detonation had predicted universes that were turbulent and chaotic due to various influences. However, the James Webb Space Telescope pictures tell a different story. Instead of savage and chaotic universes, the photos reveal smooth plates and deliberate swirling shapes resembling the universe's landscape in the modern universe. This surprising finding challenges the prospect that collisions are a normal part of structure formation. If there are few or no collisions occurring in these universes, as proposed by the theory of the universe's beginning, it becomes implausible that small worlds could grow into much larger ones. Additionally, the optical illusion expected by the expanding universe theory, where objects appear smaller with increasing distance due to expansion, doesn't seem to hold. Space specialists have observed a striking theme where galaxies tend to gather in massive clusters, forming complex associations across the universe. This observed large-scale structure aligns with the assumptions made by the theory of the Big Bang. According to the theory, the universe began in an extremely hot and dense state and then progressively expanded and cooled over time. As the universe expanded, gravity played a vital role in shaping how matter was distributed and in forming galaxies. The gravitational effects expected by the theory of the Big Bang are consistent with what we see today, with gravity organizing matter, leading to the clustering of galaxies and the development of interconnected filamentary structures, known as the cosmic web. The presence of these galaxy clusters and the cosmic web structure strongly supports the theory of the Big Bang. How galaxies are distributed across the universe aligns with the gravitational effects anticipated from the initial dense and expanding state proposed by the theory. These factors, including the clustering of galaxies, the cosmic web structure, and the distribution of galaxy clusters, provide strong evidence that the universe evolved from an extremely dense state and has been expanding for billions of years. Now we should return to the size of the galaxies found by the James Webb Space Telescope. These photographs contradict what we expected we knew about the theory of the universe's beginning. According to the speculation, small galaxies should develop and grow through collisions and mergers with other galaxies. However, observations caused by the James Webb Space Telescope feel somewhat uncertain on this idea. If galaxies were colliding and merging as expected, we would see evidence of these effects or etchings in the surrounding galaxies. However, the photos show otherwise. So, is the theory of the Big Bang essentially an idea without affirmation? No, it is undoubtedly supported by irrefutable evidence, including observations of the redshift of light from distant galaxies, which provide support for the expanding universe theory. Observations show galaxies retreating from each other, suggesting consistent expansion, as predicted by the theory. The abundance of light elements like hydrogen and helium found throughout the universe is also consistent with the predictions of the theory of how things came to be. Furthermore, the large-scale distribution of galaxies revealed through astronomical surveys matches the patterns expected by the hypothesis of early-stage Big Bang. Possibly one of the most critical pieces of evidence for the hypothesis of early-stage Big Bang is the discovery of the cosmic microwave background, CMB. The CMB is a weak radiation that fills the entire universe and represents the remnant heat of the Big Bang. This radiation, first detected in 1965, closely aligns with the predictions made by the theory of how things came to be. The observed properties of the CMB, including its uniformity and temperature distribution, strongly support the idea that the universe was once in an extremely hot and dense state before undergoing expansion. A central tenet of the theory of the universe's beginning this expansion leads us to contemplate the universe's future. As we gather more data from the James Webb Space Telescope and other advanced instruments, our understanding of cosmic evolution will likely shift. Each new discovery not only deepens our knowledge, but also raises further questions about the fundamental nature of the universe. One crucial aspect is the fate of galaxies. Will they continue to merge and form larger structures, or will they drift apart into isolation? Current models suggest that while galaxies are currently moving apart due to the universe's expansion, gravitational forces will still play a significant role in their interactions over billions of years. The idea of cosmic recycling emerges, where matter from dying stars contributes to new star formation in neighboring galaxies. Additionally, the implications of dark matter and dark energy become more prominent as we examine these cosmic structures. Dark matter, which doesn't emit light but exerts gravitational forces, influences galaxy formation and clustering. Understanding its distribution and properties is crucial for refining our models of cosmic evolution. Dark energy, on the other hand, is believed to drive the accelerated expansion of the universe. Its mysterious nature remains one of the greatest challenges in cosmology. As researchers continue to analyze the data from the James Webb Space Telescope, the quest for knowledge about the universe will not only enhance our understanding of its origins, but also offer insights into its ultimate destiny. The interplay between observation and theoretical frameworks will guide the next chapters in the story of the cosmos, pushing the boundaries of human knowledge and curiosity. In summary, the discoveries made by the James Webb Space Telescope challenge existing theories of cosmology, particularly the Big Bang model. The new data provoke questions about the formation, structure, and evolution of galaxies, leading to a reevaluation of our understanding of the universe. As we embark on this journey of exploration, we remain eager to uncover the mysteries that lie beyond the observable horizon.